I would like to demonstrate new mold design functionality in Cimatron version 10. Let's begin by going into Quick Split on this part. And the new functionality works in this way. We can analyze by draft angle up to whatever angle we want. It could be 0 degrees, minus 0.1, minus 1 degree, whatever. And we pick on a surface and we start the analysis. So it's spreading out over the solid body, looking for where it would stop at a negative 0.1 degree. And because it has knowledge of the solid model, it knows that these surfaces that are flagged in yellow probably belong to the cavity side, but it's marking them as being a potential problem because you can see that I actually have an undercut condition where the part designer made a mistake in this part. So these surfaces clearly belong to the cavity side, but they're flagged in yellow because they're trapped. And the software puts little purple dots on those areas that require attention. Over here we have some on the outside, and what the software is saying is that the draft condition of this surface makes it possible to go to the cavity side, but it's trapped under the red. So clearly this would not be a surface that would go on the cavity side. And we've got tools to address these. So if I come over here and I click on direction analysis, I can let the mouse sit anywhere on the screen and I can see the draft angles according to the surfaces that are assigned for that direction. And if I want to push these yellow ones into that group, I can toggle here and say yellow faces only. And I can then box pick, and it'll just take those guys. Whereas if I had all faces picked, I would be able to pick the gray ones as well. Okay, so that looks good. I'm going to hit the small check mark. In fact, you'll notice that if I right click anywhere here in the screen, the same feature window over here comes up underneath my mouse to make it quick and easy. The big check mark means yes, this is what I want, but take me out of the feature. The small check mark means yes, this is what I want, but leave me in the feature. So now I'm still in the feature. I flip the arrow over to the other side. I grab a face from that direction and choose Start Analysis. Alright, now we're getting quite a bit of yellow from this direction. In fact, let's take a minute and turn off the cavity side. So now we're looking at just the faces left over, which we think will go to the core side, but we're looking at these little yellow faces, and obviously this would require a lifter or slide. Over here we have a condition that would require a lifter or slide. But also I see these little pink dots up here, and I think, what's going on here? Well, here we've got another imperfection that the part designer messed up on. That solid cut didn't quite go over far enough, and it left a little sliver there that will require attention in a minute. Same thing on this side of the pocket. Alright, so basically everything that's yellow here are areas that are going to require a lifter. So I'm going to go ahead and just say select all faces and box picking over these guys, and I'm going to hit the check mark to push them all to the core side. Then let's come back here and look at this area that had a problem. Here's that sliver of steel condition. So we're going to want to get rid of that. I've got nice tools for that. Solid, remove and extend. What it really means is like delete this face, delete this face, delete this face, and then heal the solid. There we go. Also, I need it done here. And there's also one at the very end on this side. Okay, so we've got those areas fixed up. Next, we're going to use close open gaps in order to close off all of these windows. Go to the top view. And now we'll use faces close open gaps. If I have same faces toggled, it will heal the solid. If I have new faces toggled, it will give me new faces. So essentially, I'm just box picking over these areas that I want to fill. And do it. Okay, so I want to point out that if we look at this in the front view, these surfaces all have shape to them. They're not just flat, planar surfaces. In fact, some of them required more than one surface to fill the patch. So it's not just a matter of untrimming an internal boundary, it's literally rebuilding surfaces based on the surrounding solid body. And we did miss one spot. This one pocket here did not get filled, but I don't mind because at least it gave me the result. It gave me all of them except one, rather than failing and saying that it couldn't do it. So I'm just going to chain around the inside here. We'll force along the open edge so it doesn't make any wrong turns. And we'll fill that with a bounded face. And our bounded face also takes influence of the outer shape. And I think now we're ready to do the external parting faces. So let's switch these around. We'll look at the cavity side. Before we do the external shutoff faces, I need to put a little patch right here so that the outer surfaces come across this edge. So we're real quickly going to fill in this area right here. This is how we're going to do it. I'm going to create main planes here. We're going to do a parallel plane at this point right there. And then we're going to create a line from this end point going in this direction to this plane. And then we can do a composite curve across here. And a bounded face. And again, a composite curve across here. And a bounded face. and then composite curve across the whole outside. Okay, let's see how this works. Parting surface external. The draw direction is in Z. Let's see if we can get a 1-inch shut-off band around the part. Okay. Now let's zoom in here. So I don't really like that. The surface is nice and flat, but I don't like how many of them there are. So let's delete these and do something different. We're going to delete these guys. And then we'll do a composite curve like this. We'll do a regular chain. We'll go on the back side. Fill that in. Fill that in. And then we'll trim this one to that curve. Oops. Just like that. And let's do the same thing on the other side. My tolerance is a bit large here. If I make this 1/10, probably I can chain across here, no problem. And then make a surface out of those guys. Okay, now one more chain around the outside. Again, forcing along the open edge. And that just means my display state, not whether something is open or solid or anything like that. It's merely display state. Okay, parting surface external. Draw direction is in Z. And let's go 10 inches this time. Okay, that looks good. And now let's go back into quick split. And we'll assign parting attributes. Okay. Now at this point, I would bring in a mold base, so let's go ahead and do that next. Okay, that size looks okay. And we go to the end view. And let's increase the size of the cavity block. And also the size of the core block. And right now, these blocks are 1-to-1 at the parting line. And because we're going to cut in solid, we want to push them into each other a little bit. Let's also increase the ejector stroke. And let's go back, and we're going to push the fixed side in by 1 inch and the movable side by 1.5 inches. And go ahead and build it. Okay, so here we go. And what I want to do next is go to the top view. We're going to work inside the work file again. And we're going to put locks on the corners. So this is what I want to do. I want to turn off the cavity faces because we're looking at this from the core side for right now. And what we want is we want a plane parallel to X and Y at the highest point of the core. And this is where we'll sketch the lock. I'm going to the top view, I'm going to wireframe. I'm going to add reference to this corner. I go to the box tool, you sketch a size for the lock, dimension it. Okay, then we do solid, new extrude, and let's go down 3 inches, and we're going to give it taper, 10 degrees. And then let's delete these back faces as well as the bottom face. So this is clearly an open solid. And even though it's an open solid, I can still put rounds on it. Let's do 1 inch here. And 3/8 here. Okay, and let's copy that over. Alright, and then we're gonna I'm going to use a filleting command too to show how nice this, when you have to use surface fillet, how nice this is. I can fillet these 3 faces to these 3, or 2 rather. I get a preview of the result right here, the size, and I can trim and I can extend that radius all the way out to the end of the surface, just like that. That's not the right size, we'll have to come back and edit that. Let's do the other ones. what I wanted here is 375. And this one we want to change. Okay. Then I'm going to go back in the quick split for a second. And we're going to attach these faces to the same parting group as up here. And if I turn on the cavity, you can see we got the core and cavity split real nice, all the parting runoff done. And let's close. And we're now ready to cut the core block with what we have here. So this is how we do it. Over here we have cut active. We're cutting the core block with the core faces. Because there's parting attributes attached, it knows that these guys all go together. And I just say to do it. Okay, so there's the core side cut. And we know we've got lifters that need to be done, so let's go ahead and add the lifters next. Before I do that, though, it would be easier if we do this. We're working inside this block. Let's create a set. We'll call this core faces. And we're going to make it by criteria, this color. And also one that'll be called the core block. And it will be this color. So now real quickly I can turn the block on or off and the core faces on or off. I would prefer to work this way when adding lifters. First let's create a plane to add them to. Again, we're going to do a plane normal to the XY. Let's go to the front view. And for sake of time and demonstration purposes, let's do several of these lifters all on the same plane, even though they might not all be on a common plane. It'll be quicker this way. This should be okay like this. Okay, so we're going to place by this plane, and let me choose add reference. Let's pick some midpoints here. Okay, now we've got reference points to work to. Let's drop in a lifter here, and we're going to rotate this 90 degrees. And let's drop some more in. Alright, and we're going to make some changes to the size of these. So we're going to edit the leading dimension. First, let's make the Thompson rod diameter smaller. And you'll see that the feet get smaller along with the Thompson rod. We're going to make the common draft angle 1 degree. We're going to make the lifter bottom 1 inch and the width 875. Okay. Now obviously these guys are going the wrong way, so we got to spin the back row. So we're going to do individual control. And we're going to spin these guys 270. Okay, now that we've placed the lifters, I'll point out that when we place them, they actually do the cuts in the core block. Retainer plate and ejector plate. Here you'll see that it put the pockets in the ejector plate and the threads. And in fact, let's turn these guys back on for a second. When I place these, it also puts clearance in the corners. I've got my corners cleared for the car, for the Gibbs. Okay, so now let's look at doing the cuts in the lifters themselves. So the way that we handle that is we turn on the work file. And we do a lifter cut. So we're going to cut this lifter with this area of the part. And I'm just going to keep going down here real quick. We'll just make short work of this. And we'll stop here rather than go to the other side, but you'll see that. Let me hide the work file now. And let's hide the injection. Let's hide these guys. So here's all the lifters. Obviously I need to shorten my dowel pin, but each lifter is cut just like that. It's a pretty automated process.